Hello. Well, for this problem, we have a wind that is all blowing over the flat roof of a house, and then this causes the roof to lift off the house. So we just gonna draw like a little picture of what is happening in here. So we have like our flat or roof that is being lifted by the wind. And we know that the wind has a velocity of, going to put in B. B is the velocity of the wind, and it has a value of 180 kilometers per hour. We also know that the house is 6.2 meters. So this is the area of the house, of the roof, of course, and it is 6.2 meters times 12.4 meters. And we need to estimate the weight of the roof by assuming that the roof is nailed down. So what we are going to do is first to determine the pressure that this wind, that the velocity of the wind is causing the roof to be lifted. And then from there, we just simply use the relation between the pressure and the force, um, and then obtained the the force that corresponds to the weight of the roof. So what we're gonna do in here first, we are gonna use Bernoulli's equation, and this equation states that pressure 1 plus a term that is related to the velocity, this rho being the density of the wind, times its initial velocity, plus, in here we don't have any terms related to the height, so we are just going to ignore them, and we have a pressure 2 plus 1/2 of the density times the velocity squared. So we're going to suppose that the initial velocity is 0 because in the initial there is no wind, so there is no velocity, and the velocity is 0. And we can also see that what we want to obtain is the difference between the pressures, and this is equal to 1/2 the density of the wind times the velocity that we call velocity 2, but it corresponds just when the wind is blowing and then lifting the roof. So we just simply need to solve for this in here. And with that in mind, we need to know the value of the density of air. We can search for that value of air. The density of air is approximately 1.3, 1.23 kilograms per meter cube. And knowing this, we know the velocity of the wind. So we just simply need to substitute that value in there. So we will have that the difference between these two pressures is equal to 1/2 of the of density times the velocity squared. The velocity of the wind is 180 kilometers per hour. What we can do is to transform this value into meters per second. So to do that, we need to multiply this by a conversion factor. So that's what we are going to do in here. First, we are going to transform this into meters. So since we have kilometers in the denominator unit in here, we need to put kilometers in the denominator of the factor conversion, so it goes away with that. So we have that 1 kilometer is 1,000 meters. We can see that this goes away with this. And we know that 1 hour, to transform this to seconds, so we need to have hours in here. We know that 1 hour is 3,600 seconds. So we just eliminate this. And just by multiplying all of this, we just obtain that the pressure is 30.75. And we are going to see how the units goes. We have kilograms. The meter in here goes away with 1 in here, so we will have this. And seconds in the denominator, and that's it. So now to find the weight of the roof, we know that the wind is capable of lifting the roof, of lifting the roof, so that it needs to apply a force so that it equals the weight of the roof, so that the force that we can obtain, we know that force is just sorry, the force is equal to the pressure times the area of application. And we know the area of application because we are given the area of the house, of the roof, and then we can multiply this by the pressure and then obtain the force that is applied. And this force is also equal to the weight because it is the only force that is acting to prevent the roof to being lifted. So we just simply need to multiply those two values. In this sense, we don't need to transform the area because the area is given in here as meter square, so that it is 6.2, and we need to multiply that by 12.4, and this is meter square because we have meter in here and meter in here, and we are multiplying those two. So, and here we can see that this goes away with this, and we will obtain a value of I did something bad in here because the units are not the units of force, so I need to see what is going bad in here in the previous equation. Oh, okay, so as you can see in here, I forgot to put the squared of the velocity, and when we do that, the conversion factor also goes to the square. So we need to change that value. Let me just change it, and it's gonna be So now the value is 1,537.5, and now we can see that the units are different. So we will get a square of meters, so it goes away with one in here, and we will have kilometers, meters, and seconds square. So putting this value in here, we need to like change this value, only the value of the pressure. That is where I just made a mistake. So this is what we have, and now we can see that the meter square of the area goes away with this in the denominator, and we will have, let me just put this into the calculator, and this gives us 1.18 times 10 to the 5, and we can see in here that we obtain kilograms per meter, kilograms times meter per second square, which corresponds to newtons. So that we obtain good. So you see that it's very important to verify the units so you can verify that your response is correct. So this is the force applied to the roof, and then this corresponds also to the weight of the roof.